Welcome back. In today's video, we're going to be talking about decentralized artificial intelligence on the internet computer. Well, all over the blockchain ecosystem, but in today's video, we're going to be really focusing on the internet computer's interpretation and integration of decentralized artificial intelligence on the blockchain. Now, as you guys know, when I'm recording this in the middle of 2024, there's a lot of projects out there that are saying that they're going to be the mainstream AI protocol. They're bringing AI on chain. And meanwhile, none of them have a live product except for Internet Computer. And so Internet Computer has all these documents and explanations on what they're doing in decentralized AI, how the blockchain is primely ready for it. Because as you guys know, if we look at the key metrics on blockchains and compare it to the Internet Computer, there is really no comparison. Transaction per second throughput, block production, cycle burning, the number of nodes processing. It's truly decentralized, it's truly global, and we're now entering the world of artificial intelligence. And so let's get into it. Don't forget to give this video a thumbs up. We upload every single day of the year to bring you the latest happening in the financial world. So make sure you guys are subscribed to the channel. Give this video a free thumbs up because Internet Computer and crypto are not free, but thumbs up are always free. So Internet Computer describes decentralized artificial intelligence, or DAI. It's a form of AI and machine learning that utilizes blockchain technology and decentralized protocols such as ICP. ICP enables truly decentralized AI by running services on chain, providing a permissionless and secure way to run machine learning applications. Canisters or smart contracts on the internet computer can be used to host AI services and run machine learning algorithms using popular AI and machine learning frameworks and libraries. HTTPS outcalls can be used to make API calls to external artificial intelligence APIs like OpenAI, which is ChatGPT, right? And so there's already projects that are running on the internet computer or being in development for artificial intelligence, including ArcMind AI, which is an autonomous agent using chain of thoughts for reasoning and actions. You can try that in browser, actually live now. ArcMind Vector Database is a vector database that supports text, image, and audio embedding. DaVinci is an AI chatbot that uses open source large language models. You can actually look at the canister on chain yourself. Internet Computer GPT. It's a React front end that uses C++ backend running a large language model fully on chain. The Internet Computer Monist, a sort of a machine learning hello world running on internet computer. Elna AI, which we'll get to in just a minute, is a fully on-chain AI agent platform and marketplace supporting both on-chain and off-chain large language models. And we're going to get into that in just a minute to show you guys that Internet Computer is not starting to research artificial intelligence on chain now in 2024. They've been doing it for years. They've literally been doing it for years. And what's, interesting or funny about that is there's other blockchains that are only AI blockchains. Like that is their overarching category or niche in crypto. And they haven't even started development, or maybe they say they started development, but they have no actual minimum viable product. And some of these projects are worth hundreds of millions of dollars. Meanwhile, as you guys see, all of these projects that are already on Internet Computer, they're already live. Moving on, TensorFlow on ICP is an ASIL example that uses a pre-trained model for making predictions. Motoko Learn is a Motoko package that enables on-chain machine learning. Tracked Internet Computer AI is an ICP variations of Tracked. Rust Connect Pi AI to IC is an open source tool for deploying Python AI models. Juno and OpenAI is an example using Juno and OpenAI to generate images from prompts. And then there's obviously some other AI resources here if you're interested in learning more about internet computer projects on the blockchain. So there's a lot going on here in internet computer. I want you guys to understand this has been going on for years now, right? They started this technical working group on decentralized AI within their forums in November of 2023. It says, Internet Computer and I have been thought it would be great to have a technical working group around decentralized AI where we can exchange ideas, initiatives, and updates on relevant internet computer features. And so they're reaching out for feedback. And this has been a very active kind of conversation group about different types of AI and what they can implement and how they can make the internet computer better. Now, going back to Elna, which we just talked about as one of the implementations on internet computer, you can see here back in August of 2023, almost 1 year ago, the team, Brand Builder, said, "We are thrilled to announce Elna, a new AI assistant built entirely on the internet computer blockchain that allows anyone to create customized chatbots tailored to their specific needs and interests." Now, keep in mind, this was all before all the AI hype. August 2023. The AI hype started really in 2024. The only blockchain that has this already on chain. It's crazy. The Elna, you can upload your own data to train unique machine learning models that focus on niche topics and applications. Their goal is to make advanced conversational AI accessible for personal and professional use cases. I mean, think about what this can do for businesses, right? A business wants to make their customers' lives easier instead of having to call customer service or email back and forth. If they have questions about their accounts, maybe I mean, all different types of implementations from a very large standpoint, and companies want to streamline their business, right? And this is much cheaper than hiring call centers of people around the world to, deal with customers. So current AI chatbots are limited in scope and constrained by data their centralized operators choose to train them on. They said they envision an ecosystem of specialized AIs customized by users for users without being boxed in by a one-size-fits-all assistant. So you could upload documents and data sets for like teach your AI specialist about your company, shape the personality of it, deploy on chain, dynamically updating and monitor analytics. And under the hood, they use canister smart contracts that handle the AI model training and deployment, the vector database architecture for efficient on-chain data storage, Motoko components for access control, transactions, and analytics, a token-based usage model secured by the ICP protocol, and internet identity integration for seamless user experience. So as you guys can see, right, there's a lot of projects that are promising you guys the world, and they just don't have what internet computer has. They just don't have it. This is the only blockchain that I have been able to research. The only one. People are going to say, but Cryptoviser, what about Pal AI? Cryptoviser, what about Beam? Cryptoviser, what about Render? Cryptoviser, what about Fetch AI? I'm not bearish on these at all. Let me be very clear. But they don't have a live product, or shall I say live products, already on chain. This is already here, right? Like you can already go on and try these out yourself. And the demos that we've been seeing from Dominic at the DFINITY Foundation, the founder of Internet Computer, it's just the beginning, right? They're only showing us the first implementation, the very low level kind of deployment of this technology. This is just going to advance, and we're going to see more. And we're going to see more demonstrations. And the rest of crypto and blockchain are going to be looking at Dominic showing us how this all works. And they're going to be, holy shit, they're behind. Every other blockchain is behind internet computer, every single one. I mean, they even have Ask ICP AI right here, right? And so then we have to understand the limitations, not just the limitations, but how internet computer actually works, how these smart contracts work, how this is all connecting to everything. And this we can also read through, which we are in a minute. But before we go there, it's also important to understand how the internet computer's smart contracts and overall ecosystem have limitations and what the current limitations are. The internet computer uses WebAssembly as the platform for executing messages of smart contracts. Since WebAssembly is a Turing complete, it can express different kinds of computations, including non-terminating computations. The internet computer protects against non-terminating computations by limiting the number of WebAssembly instructions and other resources per message execution. The limit depends on the message type, as shown in the following table. Now, again, I don't know what all of these mean, so bear with me. I'm sure many of you don't either. But as I always explain, when you're doing research, you don't have to understand everything. But typically, if you're reading through and you're like, wait, what? I don't know what I just read. Typically, you do more research that you can understand what you just read. But I look at everything kind of to analyze the general. So needing to know all the specifics about a project, it's really not that important at all. It's really the high level, this is capable of and what they've already shown through minimum viable products or proof of concept, what they can do. So the messages per canister, the message queue limit is 500. The maximum ingress message payload 2 megabytes. Maximum crossnet intercanister message payload 2 megabytes. Subnet intercanister payload 10 megabytes. Maximum response size 2 megabytes. You can see instruction limit is 20 billion. Instruction limit, instructions per query calls 5 billion. I mean, I don't even know what that means. Who would even need to put instructions of 5 billion? 5 billion what? But again, I'm an analyst, so I'm not a technical guy. I'm not a coder, so I don't know what that means. Subnet capacity, total memory available per subnet is 700 gigabytes, which apparently is more than twice the size of the entire Cardano blockchain. So one smart contract can literally hold the entire Cardano blockchain, which is pretty unbelievable. Then you see some WebAssembly memory limits per canister. Remember, canisters are smart contracts. And so if you guys wanted all these details, just pause on the screen and you could read them. Anyway, what is the internet computer? I know a lot of you guys are invested or very bullish on this asset, but a lot of times it's important to be able to just go back to the basics, right? What is the internet computer? Because if you can't even answer that, if you're just like, oh, it's an AI blockchain, it's not. It's not what the internet computer is. The internet computer is a blockchain based on threshold cryptography, state machine replication, and novel consensus algorithms. Is that how you explain what internet computer is to people? And if you do, they probably will never ask you about it again because they won't even know what that means. It was carefully designed to give smart contracts near native performance and scalability while maintaining the security of decentralized execution. In addition to classical DeFi smart contracts such as ledgers and exchanges, Internet Computer can run compute and storage heavy applications such as image classification fully on chain. Another important design aspect of ICP is its seamless and secure integration with existing ecosystems. Smart contracts on ICP can host web assets and serve HTTP requests from users, thus fulfilling the promise of Web3. They can also interact with RPC nodes and other blockchains and Web2 servers through secure requests. These features, combined with threshold signatures, give smart contracts the ability to hold assets and make transactions on other blockchains, such as Bitcoin and Ethereum. And so we're in 2024, and you have Internet Computer that can read and write on other blockchains, and we still have blockchains that are not able to bridge or interoperate at all with the rest of crypto. So when you ask me which assets do I think are going to do the best, it's not those. It's the ones that can read and write on other blockchains like the Internet Computer. What are subnets? Subnets are basically let me reset. What are subnets? A blockchain can only run as fast and offer as much resources as a single node. One of the keys to overcome this limit is sharding, which we first heard in the Ethereum ecosystem. Internet Computer shards smart contracts over multiple instances of the blockchain. Each instance is called a subnet and has its own set of decentralized nodes running the consensus algorithm among them, building their own chain of blocks and executing smart contracts. Each subnet runs in parallel with other subnets. A smart contract on one subnet can communicate with another smart contract on a different subnet through sending messages. Users can also send messages to smart contracts. The following diagram shows the flow of messages on ICP. So you can see the user goes over to the boundary nodes or these RPC nodes, and then the message goes to the subnet, which goes to the consensus, goes into a block, goes into the state smart contract, and then executes, and then it goes back right? So then it gives the answer to the user. And so this is basically a very easy kind of description of how it works. And replicated on decentralized nodes, everything just communicates with everything, right? The message goes from one of the RPC nodes, then that node routes the message to the subnet that hosts the target smart contract. Then the consensus algorithm of the subnet adds the message to a block, and then the message is added to the input queue of the target smart contract, and then the smart contract executes the message. Steps 3 to 5 are asynchronous and decoupled from each other, which may be unusual for developers who are used to Ethereum-style atomic transactions that are executed when they're added to the block. The motivation for this design is scalability. Subnets can have different sizes. For instance, replication factors, which determine the cost of running smart contracts on that subnet. It also impacts the time to finality and security. Now, this threshold signatures we've been talking about a lot recently, specifically Schnorr signatures. Each ICP subnet has a fixed public key. The corresponding private key is not stored on a single node, nor is it ever available on any node. Instead, the public key is split into multiple secret shares and distributed over all the nodes using threshold cryptography. Nodes can collectively sign messages to other users and other subnets using these secret shares. This makes validation of the state and results trivial for users, since all they need to do is verify the digital signature against the fixed public key without downloading and validating blocks in the blockchain. This feature has profound implications and use cases for users and the internet computer ecosystem. One is there's no need to keep the blocks in the blockchain available forever, which would be a scalability bottleneck. In fact, Internet Computer actively garbage collects old blocks to keep storage usage bounded. This is a huge benefit to Internet Computer because, yeah, all these other blockchains, I mean, you open some blockchains, you got to download the entire history of the blockchain. You can be there for days, hours. That's why they create light wallets, that you don't need to do that. Smart contracts can have their own secret keys and can sign transactions for other blockchains such as Bitcoin and Ethereum. This enables trustless interaction with those blockchains. So this is another example of how that all works. And so that brings us to the smart contracts, or as Internet Computer calls them, canisters. ICP uses WebAssembly as the virtual machine for executing smart contracts. This means developers can write smart contracts in popular programming languages like JavaScript, TypeScript, Rust, Python, Motoko. And that is specifically designed for ICP. Furthermore, a single contract on ICP is powerful enough to host an entire EVM or Ethereum virtual machine. This allows the deployment of EVM smart contracts written in Solidity. A unique feature of ICP is that smart contracts can handle HTTP requests and serve web assets such as HTML, JavaScript, CSS. In other words, it's possible to write Web3 applications with both back-end and front-end fully hosted on-chain. Smart contracts can also make requests to other Web2 services outside of Internet Computer. Moving a little bit further, in terms of storage, smart contracts can store arbitrary data in their WebAssembly memory. Additionally, a smart contract can use a larger stable memory. The difference between the two memories is important for upgrading smart contracts. The WebAssembly memory is cleared on an upgrade, whereas the stable memory is preserved, hence stable. The immutable smart contract, there is no observable, for immutable smart contracts, there is no observable difference between the two memories except for the size and functions to access it. All right, so then they talk about keys and tokens and messages and cycles and governance and nodes. I mean, there is so much to learn about Internet Computer. But the bottom line is, in my view, decentralized AI, canister smart contracts, and the state of the Internet Computer where we are today, it's way ahead, way ahead. They already have AI on the Internet Computer. They've been continually building AI on the Internet Computer for at least one full year at this point, where other blockchains haven't even started. So when we're talking about investable assets, what do you think about internet computer? Let me know down below in the comments. Don't forget to give this video a thumbs up, hit that subscribe button, that way you never miss a new video, and I'll see you tomorrow. Crypto on.